Let's review half reactions. An electrochemical reaction is the sum of two half reactions, one showing the oxidation, that is, the loss of electrons, and the other showing the reduction, that is, the gain of electrons. For example, zinc being transformed into zinc ion and 2 electrons is an oxidation half reaction, and the copper 2 ion being reduced by the addition of 2 electrons to copper metal is a reduction half reaction. When added, two half reactions yield the overall reaction equation. In this lesson, we'll show a method for balancing more complex reactions. Here are the steps in balancing equations by the method of half reactions. We're going to go through these steps on this screen. Probably they won't make a lot of sense, and they won't make sense until you practice. So we'll do that on a subsequent slide. The first thing you do when you're balancing equations by the method of half reactions is you break the overall equation into two half reactions. And we'll again show you how to do that. Then we need to balance everything but hydrogen and oxygen using coefficients, just like you've always balanced equations. Then we need to balance the oxygen atoms by adding H2O as needed. In other words, we can put water on either side of the equation as we need to, such that the oxygen atoms balance. Then we want to balance the hydrogen atoms by adding H+ as needed. And here we're assuming we're in acidic solution, and if it turns out that we're told that we're in basic solution, we'll show you how to deal with that at the very end. Then we can add electrons on either side of the equation as needed in order to balance the charges. Part E here, Part 2E, says multiply each half reaction by integers to cancel the electrons. And we need to do that because the number of electrons that are lost must equal the number of electrons that are gained. And if that isn't the case between our two half reactions, then we have to multiply one or both of the half reactions by something such that the number of electrons that are lost equals the number that are gained. At this point, we would simply then add the two half reactions and simplify if we need to. In the case where we have a basic solution, we would then add enough hydroxide ion to cancel any hydrogen ion that's there, and then we would simplify again. Let's show you with an example. Balance this reaction, which takes place in acidic solution. You can see here in the middle of the screen we have an equation, and clearly this is going to involve more work in balancing this than simply putting coefficients in, because you can see that on the reactant side we have some oxygen atoms, and on the product side we have no oxygen atoms. So we can't simply put coefficients in and expect things to work out. We're going to have to use this method of half reactions. I know it's a bit small, but I've recopied the steps for balancing by half reactions here in the upper right, so we can go down the list and make sure that we've got everything. First step says break the overall equation into two half reactions. Incidentally, we're going to cross off step number 4 right from the get-go because we're told in our problem that we're in acidic solution. Once we get down to step number 3 and finish that, we're going to be done. Here's how we break the overall equation into two half reactions. We look at what's on the reactant side, and we look at what's on the product side, and we match up something that's similar. And here you can see that we have the dichromate ion on the reactant side, and then we have some chromium-3 that's on the product side. The chromiums are going to match up. That's the start for one of my half reactions, and the other half reaction is going to involve the chloride ion on one side and chlorine on the other side. Step number 1, done. Let's move to step number 2. We're going to balance everything but H and O. We're going to put a 2 in front of the chromium-3 ion because we have 2 chromiums here, and we're going to put a 2 in front of the chloride ion because that balances the chlorine atoms. So that step is done. 2b says balance oxygens by adding water as needed. In this first half reaction, we have 7 oxygens. To balance those oxygens, we're going to add 7 waters on the product side. For the bottom half reaction, we don't have to do anything because there is no oxygen. So we finish that step. Let's go to 2c. Balance H by adding H plus as needed. So in the first half reaction, we can see we have 14 H's, so let's add 14 H pluses to this side. Again, for this second half reaction, for this particular case, we don't have to do anything. So step 2c is done. Now for 2d, we're going to add electrons as needed. For this first half reaction, let's count up the charge on each side of our yield arrow. We've got 14 positives and 2 negatives. That's a total of 12 positive. On the product side, we have 6 positive and then nothing here. So that's a net, obviously, of 6 positive. On which side would we put electrons, and how many electrons would we put there such that we could somehow make 12 plus equal to 6 plus? And the answer is we would put 6 electrons on the 12 plus side, because that would take 12 plus down to 6 plus, which is what we have on the product side. When we go to put electrons in the other half reaction, we are anticipating putting electrons on the opposite side from what we did in the first half reaction. If we find ourselves, for this second half reaction, putting electrons on the left, just like we did for the first half reaction, we're doing it wrong. I'm expecting to put electrons over here, and if that's not the case, we've messed up and we need to start over. I think what we're going to find here is 2 minus is the net charge on the left, 0 is the net charge there, so sure enough, we need a couple of electrons on that side in order to make the charges balance. So step 2d is now done. Step 2e says multiply each half reaction by integers to cancel the electrons. In other words, the number of electrons here, 6, needs to somehow be made to equal the number of electrons here, which is 2. So I think what we need to do is take the bottom equation and multiply the whole thing through by 3. I've changed the 2 electrons to 6 electrons. I've changed the 1 Cl2 to 3. I've changed the 2 chlorides to 6 chlorides. We can see now that the electrons cancel. So step 2e is done. Now let's go to step 3, add the 2 half reactions and simplify. So here we go. I'm going to bring my 14 hydrogen ions down. I'm going to bring my dichromate down. I'm going to bring my 6 chlorides down. And on the product side, we're going to bring our 2 chromium 3s down, our 7 waters, and our 3 chlorines, and we're done.